All right. So we are going to start here. Given the regular polygon below, just a reminder, regular means something to us. Regular means all sides are congruent, all angles are congruent, right? Like two things are true. And polygons, right? Basically every shape that we've seen is a polygon. It encompasses all shapes, right? Label one interior, one exterior, and one central angle. So one interior angle, you go to any corner, right? And you just make one of these. And I would have expected you to put an eye there. If you didn't do that today and you're like, that's what I meant, you would get the mark there. An exterior angle, you can go to any corner as well. I'm going to choose to do it right next to this one. Pick one of the sides and just travel along it until you get to the end, and then just keep going in that same direction. That right there is called an exterior angle. Okay. And a central angle, you go to the center, pick any side, right? So let's say you pick this side right here. I go to one corner, trace to the center, go to the other corner, trace it to the center, and that is a central angle like that. You need to know where they are. And the answer is the number of sides coincides with the number of central angles, the number of interior, and the number of exterior angles, right? Like they all match. And we're going to make a note. 1, 2, 3, 4, 5, 6, 7, 8, 9. The number of sides, N stands for the number of sides, which is no news to you if you watch the video. But that's important with polygons, regular polygons. It helps us find stuff. The sum of interior angles, sum of a 9-sided polygon, would be n minus 2 times 180 degrees. And that's basically 7 times 180, which is 1260. So if you have that with a degree symbol, you get a mark. 3 marks for the top one, by the way. 1 for each correctly labeled and identified angle. Calculate the measure of one interior angle. So if you want to go with a formula, right, that'd be n minus 2 times 180, which is exactly the same as before, divided by 9. So I know that the top is 1260. I'm going to divide it equally amongst the 9 angles that exist, and it's 140 degrees. Each eye, right, is 140 degrees along to add up to 1260, right? The measure of one exterior angle, 2 ways to do this. You can use the formula, which is 360 divided by n, right, which is 40, or you know that, right, the interior and exterior add up to 180, so you could have just subtracted this from 180 to come up with that. Calculate the measure of a central angle. Central angle is the same as the exterior. It's also 40. Got a mark for that. Calculate the number of diagonals that could be drawn in this particular polygon. If you watch the videos, you know what I'm talking about. But the formula is right this. Diagonals of a 9-sided polygon is n times n minus 3 divided by 2. That's the formula. And I did give you a couple here, right, to save you a little bit of trouble. This is diagonals right there. And that would be 9 times 6 divided by 2. And that would be 27 diagonals. If you have 27, that's fine. Okay. The sum of all exterior angles, what do all exterior angles always add up to? 360 degrees. Right? It's always 360 for exterior angles. It doesn't matter how many angles there are. So this page is worth 1, 2, 3, 4, 5, 6, and another 3. That's 9. 9 for that page. And then you basically repeat the whole process one more time. Back side. If a polygon has a central angle of 20 degrees, so they're basically saying, hey, if C is 20 degrees, right? How many sides does it have? How many sides does it have? It's asking you for n, right? Calculate this. I don't want you to guess it. So central angle, the formula is this, right? We know that C is going to be replaced with 20. So you just go like that. Put a 1 underneath here. You know you have to multiply and then divide. So n is 360 times 1 divided by 20. Okay. That gives you 18 sides. So I'd like to see work like this work where you use a formula, you plug in. You can skip the actual formula. You can just show me how you already substituted the left side. Cross multiply and divide. Okay. 2 marks for that if you showed me work. Regular hexagon, what is that? If you remember, it tells you that there are 6 sides for this shape. And let's just go through this would be 6 minus 2 times 180. The sum would be 4 times 180, which is 720. A central angle would be 360 divided by 6, right? That's 60. One interior angle, that would be n minus 2 times 180 divided by 6. And that is 720 divided by 6, which is 120. So basically, if you get n wrong, you will get 1 minus 1, and then the rest I would always just assume follow through error. So if you, let's say you thought it was a 8-sided for whatever reason, you would lose 1, and then I would just follow your work. Okay. Number of diagonals, that would be n times n minus 3 divided by 2, so that's 6 times 3 divided by 2, and that's 9 diagonals. That would be you could draw on this one. Measure of one exterior angle. One exterior, that's just 360 divided by 6, which is also 60 degrees. Everything is worth 1 mark. And this one I'm curious to see how you did with this one. This is definitely not a regular polygon. You know right away the angles, like they all need to be exactly the same, right? It's not regular. So, but the sum of interior angles works for any regular or irregular. So you count 1, 2, 3, 4, 5. N is equal to 5 here. Okay. So then the sum of a 5-sided shape would be n minus 2 times 180, and that's 3 times 180, which is 540 degrees. You would get 1 mark for that. And then how would you find angle x? Right? X would be 540, so all these add up to 540. Just start subtracting, right? 90 minus 90 minus 149 minus 151, and that gives you 60 degrees. You get another mark for that. Right? So 1 mark for that one, 1 mark for the other. So this page is 2 and 5 is 7, another 2 is 9. So 9 marks for this back side. 9 and 9 is 18. So you get this back, so you can write down the correct answers. You're going to get something similar again tomorrow. Just making sure, right, if you know how to work with polygons. And this is the basics for polygons. Today we're going to do a little bit of sides. Like this is all angles. Now we're going to use that to also figure out the side lengths of polygons. Okay. So 9 and 9, 18, top right corner, right? Make sure there's a mark there. Question? Okay, I'll be right there.